The scientific revolution was a time of huge change. Old ideas were questioned and new discoveries were made. Leading this revolution was Christiaan Huygens, a Dutch scientist who knew a lot about many different things. Huygens made amazing discoveries in physics, astronomy, and math. His work changed how we understand the universe. His inventions, like the pendulum clock, greatly affected everyday life. Christiaan Huygens was born in The Hague, Netherlands in 1629. The Hague, during the 17th century, was a bustling city known for its political significance and cultural vibrancy. It was a place where the elite and intellectuals of the time gathered, making it a fertile ground for someone like Christiaan to grow up. He came from a rich and important family. The Huygens family was well respected and influential, with deep roots in the Dutch nobility. Their wealth and status afforded them a lifestyle of comfort and privilege, surrounded by the finest things in life. His father, Christiaan Huygens, was a diplomat, poet, and art lover. Constantin was a man of many talents and had a significant impact on the cultural and political landscape of the Netherlands. He was a close advisor to the House of Orange and played a crucial role in the diplomatic affairs of the time. Their home was a meeting place for smart people and artists. The Huygens household was a hub of intellectual activity, frequented by some of the most brilliant minds of the era. Philosophers, scientists, artists, and writers would gather in their salon to discuss ideas and share their work. Young Christiaan grew up in this exciting environment, surrounded by books, art, and scientific instruments. He was exposed to a world of knowledge and creativity from a very young age. This stimulating environment undoubtedly played a significant role in shaping his inquisitive mind. He learned about the newest scientific and philosophical ideas. The 17th century was a time of great scientific discovery and philosophical debate, and Christiaan was at the heart of it all. He had access to the latest works and theories, which fueled his passion for learning and discovery. Christiaan got a great education. His parents ensured that he received the best education possible, hiring private tutors and sending him to prestigious schools. His education was comprehensive, covering a wide range of subjects from the humanities to the sciences. He studied law and math at the University of Leiden. The University of Leiden was one of the leading educational institutions of the time, attracting students from all over Europe. It was here that Christiaan honed his skills in mathematics and developed a deep understanding of the law. He later continued his studies at the College of Orange in Breda. This institution was known for its rigorous academic programs and emphasis on critical thinking. Christiaan's time at the College of Orange further broadened his intellectual horizons and prepared him for his future endeavors. He was great at math from a young age. Christiaan's natural talent for mathematics was evident early on. He excelled in his studies and quickly gained a reputation as a prodigy. His ability to solve complex problems with ease set him apart from his peers. He was also really interested in astronomy and mechanics. Christiaan's curiosity knew no bounds. He was fascinated by the workings of the universe and the principles of mechanics. His interest in these fields would later lead to groundbreaking discoveries and innovations. One of Huygens' most important discoveries was his wave theory of light. This theory was revolutionary for its time and laid the groundwork for our modern understanding of light and optics. Huygens proposed that light travels in waves, a concept that was quite different from the prevailing theories of his era. Back in the 1600s, Isaac Newton's idea that light was made of particles was the most popular. Newton's particle theory of light suggested that light was composed of tiny particles or corpuscles that traveled in straight lines. This idea was widely accepted because it could explain many optical phenomena such as reflection and refraction. However, Huygens challenged this idea with his wave theory. He said that light travels in waves like ripples in a pond. Just as ripples spread out when a stone is thrown into water, Huygens believed that light waves spread out from a source. This wave-like behavior could explain certain optical effects that Newton's particle theory could not. He imagined light moving through an invisible stuff called the luminiferous ether. This ether was thought to be a medium that filled all of space and allowed light waves to propagate, much like sound waves travel through air. Although the concept of the luminiferous ether was later disproven, it was a crucial step in the development of wave theory. Huygens' wave theory explained how light bends around corners, which is called diffraction. Diffraction occurs when light waves encounter an obstacle or a slit that is comparable in size to their wavelength. This bending of light was difficult to explain using Newton's particle theory, but it made perfect sense in the context of wave theory and how light waves affect each other, which is called interference. Interference is a phenomenon where two or more light waves overlap and combine to form a new wave pattern. This can result in areas of increased brightness, constructive interference, or darkness, destructive interference. Huygens' wave theory provided a clear explanation for these patterns, which were observed in various experiments. These things were hard to explain with Newton's particle theory. Newton's theory could not easily account for the bending and overlapping of light waves, leading to significant debates and discussions among scientists of the time. Huygens' ideas were initially met with skepticism and resistance. At first, people didn't accept Huygens' ideas. The scientific community was deeply rooted in Newtonian physics, and the wave theory of light was seen as controversial and unproven. However, Huygens continued to advocate for his theory, conducting experiments and publishing his findings to support his claims. But experiments in the 1800s later proved him right. The work of scientists like Thomas Young and Augustin Jean Fresnel provided strong experimental evidence for the wave nature of light. Young's double-slit experiment in particular demonstrated the interference of light waves, further validating Huygens' theory. By the 19th century, the wave theory of light had gained widespread acceptance, paving the way for future discoveries in the field of optics and electromagnetism. Before Huygens, clocks weren't very accurate. Timekeeping was a challenge that many civilizations tried to tackle in various ways. The methods they used were often rudimentary and imprecise, leading to significant errors in time measurement. They used simple methods like falling weights or flowing water. These early clocks, while innovative for their time, lacked the precision needed for more advanced applications. Water clocks, for instance, relied on the steady flow of water to measure time, but they were susceptible to changes in temperature and pressure. Similarly, clocks that used falling weights could be affected by friction and other mechanical issues. Huygens changed timekeeping forever when he invented the pendulum clock in 1656. This invention marked a significant leap forward in the accuracy of clocks. The pendulum clock was revolutionary because it introduced a new level of precision that was previously unattainable. Huygens' work laid the foundation for modern timekeeping. He figured out that the regular swing of a pendulum could control the movement of a clock's gears. This discovery was based on the principle of isochronism, which means that the period of a pendulum's swing is constant, regardless of its amplitude. By harnessing this principle, Huygens was able to create a clock that kept much more accurate time. Huygens' pendulum clocks were much more accurate than any other clock before. This increased accuracy had profound implications for various fields, including science, industry, and daily life. People could now rely on clocks to keep consistent time, which was essential for scheduling and coordination. This invention was really important for navigation. Accurate timekeeping was crucial for determining longitude at sea, which was a major challenge for sailors. Before the pendulum clock, sailors had to rely on less accurate methods, which often led to navigational errors and shipwrecks. Sailors could now figure out their location at sea much better. With the advent of Huygens' pendulum clock, they could calculate their position with greater precision, reducing the risks associated with long sea voyages. This advancement made it possible for explorers to venture further and map new territories with confidence. This made sea travel safer and faster. The ability to navigate accurately meant that ships could follow more direct routes, saving time and resources. The pendulum clock thus played a pivotal role in the age of exploration, enabling the expansion of trade and the exchange of ideas across continents. Huygens also loved astronomy. He made important discoveries about our solar system. He was especially interested in the planet Saturn. In 1655, using a powerful telescope he designed and built, Huygens made an amazing discovery. He saw that Saturn wasn't just a ball. It had a thin, flat ring around it. This ring was tilted compared to Saturn's path around the Sun. Huygens' discovery solved a mystery that had puzzled astronomers for centuries. They had wondered why Saturn seemed to change shape. Huygens wasn't satisfied with just discovering Saturn's rings. He also wanted to understand what they were made of. He believed the rings weren't solid. Instead, he thought they were made of many tiny pieces, each going around Saturn. Huygens' observations and ideas about Saturn's rings were groundbreaking. They showed how telescopes could reveal the amazing secrets of the universe. His work helped future scientists study planetary rings. Besides physics and astronomy, Huygens also made important discoveries in math. He was one of the first people to study probability theory. In 1657, he published his important book. In this book, Huygens explained the math rules for understanding games of chance. He introduced ideas like expected value and probability distributions. We still use these ideas today in fields like statistics, finance, and risk assessment. Huygens wasn't just a brilliant thinker, he was also a skilled toolmaker. He designed and built his own telescopes, which were some of the most powerful of his time. He also invented the Huygenian eyepiece, a special lens for telescopes that made images clearer. The Huygenian eyepiece greatly improved how well we could see through telescopes. It became a standard part of telescopes for centuries. Huygens' work on telescope design really helped advance astronomy. Christiaan Huygens died in The Hague in 1695. He left behind amazing discoveries and inventions. His wave theory of light, his pendulum clock, and his discoveries in astronomy changed how we understand the universe. Huygens' work still inspires scientists today. He reminds us about the power of curiosity, observation, and the constant search for knowledge. He was a true giant of the scientific revolution and will always remember his contributions to science.